Let h be a function defined for all x except 0 such that h of 4 equals negative 3 and the derivative of h is given by h prime of x equals x squared minus 2 over x for all x except 0. So A says, find all values of x for which the graph h has a horizontal tangent and determine whether h has a local maximum, local minimum, or neither at each of these values. Justify your answers. So if you want to find the local maximum or the local minimum, you should first find the critical values. The way to find critical values is first, you make x prime equal to 0. So if you find all the critical values, x equals negative square root of 2, 0, square root of 2. So you make a number line to determine the sign of each region. So it's negative plus negative plus. So we see that the local minima is at x equals negative square root of 2 and at x equals square root of 2. B says, on what intervals, if any, is the graph of h concave up? Justify your answer. To find the concavity of functions, you have to find the critical values of the double prime. So if you first find the derivative of h prime, it will be 1 plus 2 over x squared. So if you see the double prime of h is always greater than 0 for all x except 0. Therefore, the graph of h is concave up for all x except x equals 0. C says, write an equation for the line tangent to the graph of h at x equals 4. So if you want to find the tangent line, you should first find the slope, which is the derivative. So if you find h prime of 4, it will give you the value of 7 over 2. The problem states that h of 4 equals negative 3, so it can be y plus 3 equals 7 over 2 and parentheses x minus 4. D asks, does the line tangent to the graph of h as x equals 4y above or below the graph of h for x greater than 4 and y? As you can see at B, we stated that all of the values except x equals 0 has a concave up. Therefore, we can state that the tangent y is below the graph.